So I'm really excited to welcome you all here today. For those of you that don't know me, I'm Maria Papas, I'm the Assistant Dean for Research, Innovation and Postgraduate Support in the faculty. So thank you for taking the time to attend our 3-minute thesis competition hosted by our faculty. And in fact, we're the only faculty in the university that hosts this event. And this year marks the second year that we're having this. So the 3-minute thesis, or 3MT, challenges participants to distill their complex research into a clear, engaging presentation that lasts just 3 minutes. And it's accompanied by a single slide. So this unique format not only hones your communication skills, but also emphasizes the importance of making research accessible to a broader audience. So it's a really tough ask to do, and I can guarantee you that the majority of people in the faculty would really struggle with this. Now, the 3MT competition was founded by the University of Queensland in 2008, and it's grown since then into the format that has been adopted by many top universities globally. And in fact, the competitions are held in over 900 universities across more than 85 countries worldwide. So we've agreed to become part of that network, and we follow the format. And the judges use the scoring sheets provided by the people that manage this. So we hope to achieve 3 things with having the 3MT competition. So other than the prestige of being a winner and getting money in your pocket, we want to focus on, firstly, skills development for our research candidates. So participating in the competition develops academic, presentation and research communication skills, while developing the PhD candidate's ability to effectively explain their research in language that's appropriate to an intelligent but non-specialist audience in 3 minutes with obviously limited visual aids, and that's just the one slide. It encourages you to think critically about the work, identify the core message, and present it compellingly. So skills that I hope you will realize are essential, not only in academia, but as you step into a different professional setting. So think of the 3MT as a way to prepare an elevator pitch, where you narrow down tens of thousands of words where you've written your thesis, and countless hours, we won't even add how many hours you've but spent on your PhD, into a 3-minute presentation. So it enhances your ability to communicate the bottom line, why. Okay, why does your research matter, and why does it make a difference? It'll also provide you with the opportunity to receive some constructive feedback from a very different kind of audience than you normally would. So our second reason for having the 3MT competition is because we want to build a stronger research culture in our faculty and across the university and universities. So 3MT provides a valuable opportunity for PhD candidates, their supervisors, and all of our researchers to come together to get to know one another and talk about the research. It should also provide a supportive environment in which schools, research entities, and the university can provide presentation skill training. So you know the research office does offer presentation skills training. This is a unique presentation skill, and I think as it becomes more popular in our faculty, we'll start introducing workshops to help people do this better. Lastly, building external relations for the university, and this is something we're building towards. As I said, we're part of a big international network. Once we get big enough, and there's more buy-in from the faculty to participate in this, we will start looking at sending the winners to national and international 3MT competition, and this would obviously provide an excellent networking and professional development opportunity for all the candidates. And globally, previous 20 finalists have benefited from invitations to a whole host of networking events following their participation in this competition. So the event gives the faculty the opportunity to celebrate the exciting and outstanding research that is being conducted by you guys, our Doctor of Philosophy candidates. And each presentation will provide unique insights into the significant contribution each of you have made to health sciences. It's also an opportunity for the PhD candidates to showcase their hard work and take the time out to brag. You've earned it. So I congratulate you guys for being brave, because I think it takes a lot of courage to stand up, to agree to do this. As a side note, the faculty from next year, all new PhDs are going to have to do an oral defense for their PhDs. So, whether people like it or not, they're going to have to participate in an oral defense. And I think events like this will start becoming compulsory for our PhD candidates, because we want to make sure everybody has as many diverse skill sets as possible when they leave here. So I'd like to just run through the process before we start. So I will introduce each presenter and then tell you the title of the talk. We'll run through also the supervisors. I think each of you have got the little booklet in front of you, but I will do that. So I don't want the candidates wasting time giving us the title, telling us who their supervisors are, wasting time. Just hit the ground running, okay? So we'll get to your slide, you hit the ground running. So you'll then have the challenge of explaining your research guided by your slide in under 3 minutes, and the clock will start ticking. So Laura over here, who I don't know if most of you have met face to face, is the timekeeper. So smile at her. Now, if you go over the 3 minutes, we won't stop you. But then Laura will let the judges know that you've gone over time, and we will likely remove points. So there is a scoring system, and the judges are looking at different things. Obviously, keeping to time is one of them. Okay. And don't waste any valuable time thanking the organizers and your supervisors. They all know that you thank them. Okay. So this presentation isn't about that. And as was publicized, the first prize winner will take away 20,000 rand, second prize is 10, and third prize is 5,000 rand. And that will go into your personal bank accounts, so you can go Christmas shopping. There's nothing for the judges, other than the knowledge that you've made somebody really happy over the December holidays. Yeah, so I hope you've brought your energy, enthusiasm, and all of your expertise, and let's have a fun morning. And I hope this event ignites your curiosity about the fascinating research that we do in the faculty. So let's start with our first contestant. So our first candidate is Saira Abdullah. She's supervised by Professor Jane Gooch, Adjunct Professor Leslie Robertson, and Dr. Sherry Crowler. And her thesis looked at strengthening community-based collaborative care for people living with severe mental disorders in South Africa.
Anna is an unemployed woman who has severe mental disorders such as schizophrenia, bipolar disorder, and major depression. She also has comorbidities including heart disease and diabetes. Anna is reluctant to go to access healthcare services in the hospital because she doesn't like going there. Anna is not alone. There are many people who are just like Anna. It is estimated that an estimated 25, this is nerve-wracking. Doesn't matter how many times you practice. So as I was saying, It is estimated that the lifespan of a person living with a severe mental disorder reduces by 25 years. That's a huge amount of life lost. Anna is someone who will benefit from something called an integrated care, where she can actually access services in the community, where she can get services without going to the hospital, and she can actually go and access integrated mental health care services within a community where she can get comprehensive care for physical and mental health care. My PhD evaluated this integrated service in Zedwayne District. The aim of the project was also to look at the collaboration between multidisciplinary providers who delivered care to healthcare users in an integrated care setting using a collaborative care model. The aim of the collaborative care model is to improve teamwork and shared decision-making together as a whole in order to improve patient outcomes, reduce hospital admissions, and improve quality of care for people like Anna. To do this, we looked at 2 clinics in Zedwayne District. The first is a physically integrated site where care is provided, community psychiatry services are fully integrated in integrated care settings. So what this means is that it has shared space and it has shared resources. In the co-located site, we found that there was community psychiatry services are provided in a building next to primary health care, and it's separate and it operates independently of each other. The findings suggested that collaboration and integration were very much co-intertwined. So basically what this means is that for integration, in the physically integrated site, there was poor resources, there was insufficient space, there was really bad infrastructure, but it had really great management. And what this actually led to was really good cohesion between the team. And it also meant that people were able to work together better because they were in close proximity to each other. In contrast, the co-located clinic had better resources, and it had better infrastructure, but it had really bad management, which related to a hostile work environment. This also meant that because the buildings were separate, the multidisciplinary team could not communicate together. In essence, what we found is that having a physically integrated site with good management results in really good opportunities for collaboration and teamwork and care coordination. And it doesn't just require integration, and it requires a system where there's teamwork, good management, and really great resources. Thank you.
It's the worst being the first person up, right? Or waiting to go last. And I think well done. Great. Okay, so our next speaker is Philomani Takalani. And he's been supervised by Professor Yaya Chinara, Pradeep Kumar, and Pierre Pandier. And the project is titled The Development of Nanoparticle Infil Matrix for Enhanced Antiretroviral Drug Absorption in the Female Genital Tract. Over to you.
This study focused specifically on HIV and AIDS in women, since HIV infections have been reported to initiate in the female genital tract. Now, TDF, as I've shown here, is one of the most effective antiretroviral drugs used to prevent and treat HIV infections. However, using this drug for a long period results in renal and bone cytotoxicity, because its dose of 300 mg is too high. This causes patients to be discouraged from using these pills on a daily basis. So, from a pharmaceutical research perspective, we can develop nanomedicine to combat and reduce HIV and AIDS, which is why we developed alginate and neutrogene nanoparticles containing 60 mg of the TDF drug. So this dose was chosen based on the solubility of the drug. The goal of the study was to reduce toxicity and to prolong the release of the TDF drug. Now, compared to TDF pills, which release for which released for only 8 hours, and it's the reason why patients take them on a daily basis. The release of TDF from the nanoparticles we developed lasted for 96 hours, which is 4 days. And since this is a vaginal study, we first tested the toxicity of these nanoparticles in vaginal cells in vitro, and we found that the particles they were not toxic to the cells for about 72 hours. So this gave us a go-ahead to now do animal studies. But since these nanoparticles are in a powder form, we had to incorporate them in the films, which are in the films that are solid, so that we could be able to insert them in the vagina of the pigs. And this was to assess the toxicity in animal studies. And the pigs were chosen based on their anatomical resemblance to humans. So the results we found here, the anatomical, the histopathology findings showed mild to moderate changes when this delivery system is inserted in the vagina for 4 days. So, in conclusion, this study indicates that TDF and alginate nanoparticles incorporated in the HPLC films have the potential to reduce toxicity, to preserve and also sustain the TDF release in the female genital tract. Thank you.
Okay, so we're moving on to our third candidate, Sahana Dinat, also supervised by Professor Sandy van Vuren. Thanks, Sandy, for attending, and Dr. Elaine Orchard. And the title is slightly different, but it's South African Natural Alternatives for the Treatment of Helicobacter pylori and Gastric Ulcers. So, the floor is yours.
Did you know that up to 84% of South Africans are infected with Helicobacter pylori? H. pylori is a bacterial pathogen that lives in the gut and is implicated in multiple disorders. Most notably, it's the bacteria that causes ulcers. Conventional treatment makes use of 3 to 4 different antibiotics along with other drugs, but this is increasingly losing its effectiveness since H. pylori gains resistance to antibiotics very quickly. These multiple antibiotics are not just going to target H. pylori alone either. Instead, they target multiple essential groups of bacteria that form part of the gut microbiome. These are groups of bacteria that play a role in the functioning of our gut. The aim of this project was to find alternatives that can effectively treat H. pylori infections while maintaining the natural gut microbiome. 155 natural products were collected from around the country, and these included plants that are used traditionally for treating gastric ulcers and bee products like honey and propolis. Propolis is like bee cement that is used in the hive. These products were then tested for their anti-H. pylori activity, their effect on the gut microbiome, as well as their toxicity. 87% of the natural products did have anti-H. pylori activity, with noteworthy activity seen for 41%. When we took a look at their effects on the gut microbiome, 72% of the products had no adverse effect on probiotic bacteria that would occur naturally in the gut. And when we combined these probiotic bacteria with the natural products, we saw up to 4-fold increases in the anti-H. pylori activity. When investigating toxicity, almost all the products were not toxic, with only 5 plant extracts considered to be toxic. Taking everything into account, the overall best activity was seen in plants like mother-in-law's tongue, which is the first one, and then pepperbark tree, the second one, and bee products like boohoo and citrus honey, as well as Western Cape brothers. These results show the potential of these products for treating H. pylori infections and other antibiotics, with no adverse effects on the gut microbiome. These products could serve as effective, easily accessible, cheaper options for treatment. A solution from South Africa for South Africa. Okay.
I hope everyone's enjoying this. Okay, great. So now we move on to Devesha Essa. She's been supervised by Professor Yahya Chinara, Pradeep Kumar, and Mandeep Kaur. And her PhD was titled Design of a Smart Stealth Nanosystem for Targeting Drug Delivery in Prostate Cancer Treatment. What happens that again?
Imagine you're a cancer drug. And after administration, you move along the bloodstream, but then there's these immune proteins that surround some of your molecules and carry them away for elimination as waste. You lose many molecules this way, and you require a higher dose of drug to compensate for this loss, which is not good for the patient. Well, you soldier on anyway to treat the cancer, but you can't tell the difference between cancer tissue and healthy tissue, so you destroy them both. And the damage that you cause to the healthy tissue results in severe side effects for the patient that you are trying to treat. But what can be done? Well, now imagine you're still a cancer treatment, but this time you're a nanoparticle made of special biomaterials that shield the cancer drug inside you from the immune system, giving you the time you need to get to where you have to go to treat the cancer. And on your surface, you have these molecules that act as keys with a unique shape that only fit the lock-like projections called receptors that are only found on the cells that you're trying to treat. So you only have access to the cancer tissue through these locks, and you leave the healthy tissue alone. This vision is realized by my research, where I design nanoparticles to shield cancer drugs from the immune system, and I attach antibodies on the surface of the nanoparticles to bind to receptors that are only found on prostate cancer tissue. So my research is on designing a treatment for prostate cancer, which is a growing disease that is especially relevant in our African context, as it is more prevalent and more aggressive on the Black population. I tested this nanoparticle system on 3D tumor spheroids, which model the growth of tumors in patients, and I found that the nanoparticle system caused a 50% more tumor shrinkage compared to the free drug, and the nanoparticle itself caused no toxicity on healthy cells, proving the higher efficiency of the nanoparticle system. In fact, this novel and innovative system has many possibilities for future development, such as changing the surface molecules to target different cancers we might want to treat. So, as we look to the future, we can use this nanoparticle system to improve efficiency, lower drug doses, and reduce side effects, all with the aim of improving the quality of life for cancer patients in Africa and worldwide. Thank you.
Right, so our next candidate is Arthur Manjatika, supervised by Dr. Joshua Davines and Dr. Petasai Mazingenia. And he looks at the examination of the metatarsal nutrient for arena. Don't laugh if I said that wrong. And I guess, okay, the implications for forensic analysis and morpho-functional adaptations in 19th and 20th century individuals. Thanks.
Okay, if we are to take an X-ray of your food, this is how it will look. So most of the fractures of the food usually happen to the bones that have been labeled as the metatarsals. And these fractures are usually at the level of the nutrient foramina, which has been presented by this P. So nutrient foramina is that opening which is carrying blood vessels to the bone. So if fractures are there, it means there will be delayed healing as the blood flow will be disrupted. So we had 3 questions. The first 2 are clinical, which we have to say how do we manage fractures of the metatarsals. To do that, we need the topography. But the topography is believed to vary depending on the population specificity. So what we did is we physically examined metatarsal bones from 3 South African populations, black, white, and colored, and we found out that there are no population differences, meaning to say it is now, this information is now predictable. In the same process, we also managed to bring in a new understanding of the size and number distribution of the nutrient foramina. Then we went with the second question, which was also critical, to say if factors are happening at this level, why is that the case? Would it mean that this is a natural weak area? To do that, we did an advanced scanning, which is microscopic scanning of the black, white, and cat South African populations. Contrary to our expectations, we found out that the area around the nutrient formula is the strongest of all the areas that we scanned. At the same time, its peak strength is between 21 to 30 years. And there are no population differences. Even if we are to compare those that lived in the 19th century and 20th century, they all exhibit the same strength. Then we went to our third question, which was forensic in nature. Just imagine you have been killed by your enemy, and because they don't want to be discovered, your bones have been thrown all over. And fortunately, one of the metatarsals has been found. Can we tell from that metatarsal the measurements around the nutrient foramina whether you are biologically male or female? So in forensic, the formula that will develop, if they are 75% and above, they are considered appropriate. So in our case, we took direct measurements of the black, white, and cat South Africans and used the two main statistical methods, discriminant function and logistic regressions. So we found out that yes, we can tell whether you are male or female, you up with 75.9% accuracy rates. And that is population specific. Thank you.
Okay, our next candidate, I see you've shortened your name. and I did count the letters in your surname. There are a couple less than mine. So, okay, Kuda Miyamuka. I did practice the full name. Alright, so Kuda's been supervised by Professor Michelle Ramsey, Colin Masenirengwa, and David Twesigomwe. And the title is Genetics of Hypertension Management in Black South Africans. Over to you.
So imagine the M1 at any given time, at any given day, on any given day. And basically what you're imagining is a highway with cars on it. So the highway is like the blood vessels in the body, and the blood is like the cars which are traveling on the road. So hypertension is now the M1, maybe on a Friday at about 4 p.m., where there's a lot of cars and your heart is having to overexert itself to keep that traffic moving. So there are many things which cause hypertension, and there are many ways to treat hypertension. And in my study, we focused on a group of medications which reduce the volume of blood in the body. So in other words, they work to reducing the number of cars on the road. That way your heart doesn't have to work as hard. And we focused on this group of medications because that group, along with another group called calcium channel blockers, which targets the heart, are recommended for Black people, or more accurately, people with African ancestry. And they're the most prescribed for those people, including here in South Africa. So the problem is the studies which informed this decision were done in European, Asian, and American populations, and they don't know the reason behind this particular phenomenon. So we thought we would investigate whether the reason was genetic. So to do that, we first had to build a cohort. So we did an observational study in Soweto and followed 364 patients through their treatment journey from the time they were first diagnosed and through their follow-ups. And we found that 51% of them managed to gain control of their blood pressure by the time they returned for their first follow-up. So then we did some genetic experiments and analyses to see if there were some genetic differences between those who responded to their treatment and those who didn't respond to their treatment. And in terms of genetics, unfortunately, we didn't have enough people to find any definitive variants which either cause or prevent people from responding to their medication. But we did find some novel variants which had never been described before. And we also found that some of the variants in those European, Asian, and American populations which were found to contribute to response were in different frequencies in our cohort. So in other words, those variants may have been common in those populations, but they were actually rare in our cohort. So what does this mean? To put it plainly, hypertension is complicated, and its management is actually dependent on many other factors outside of medication. In terms of genetics, in order to know how much genetics plays a role, because it does play a role, we need to do bigger and better studies to know exactly how much it does. But what plays a bigger role is actually one, our lifestyle, so what we live, how we live and what we eat, and two, the challenges to our healthcare system. So getting patients to come back for follow-ups, getting them to take their medication. But this is encouraging because despite all of that, people in Soweto, about half of the people in Soweto are able to gain control of their blood pressure. And this means that obviously the things that we can do are what's actually needed in order to improve the management of hypertension. Thank you.
All right, so our next candidate is Campion Zarima, supervised by Professor James and Professor Francis Griffiths. And he's going to talk to us about the challenges and strategies to ensure implementation of quality electronic health records in South Africa.
So South Africa is planning to implement the National Health Insurance Fund. To those who don't know what it is, essentially we put money in one pot and then we pay for every South African citizen's healthcare needs. But part of what makes that work is to have systems in place, robust systems that ensure that there's monitoring of the strategic purchasing and the use of these funds. So my PhD looks at electronic health records, which is essentially what is required for the success of the NHI. Literature shows that for implementation of electronic health records, there's predominantly two approaches, which is the bottom-up and the top-down. The top-down is essentially when high-level people, managers, just decide or purchase a system off the shelf and then essentially give it up for implementation. Whereas the bottom-up approach is when systems are designed with user input. They're involved in deciding which systems to use or how to design them for their workflow. So with these two approaches, my PhD essentially tried to see how these affect South African implementation of EHRs. And so for the top-down, I did interviews with 18 high-level people, managers from the Department of Health, provincial, national, policymakers, etc. And they all seem to agree about one thing. That South Africa has the right policies in place, it also has the funds to implement or to embark on this project. But the problem is that the leadership simply isn't fully aligned with the vision to implement electronic health records. So obviously they tend to make decisions that are not in the interest of implementation. And then I went on to look at a case study of a system that was implemented in Ekurhuleni as part of my bottom-up. And then I realized that the system was implemented well, there was good groundwork, the implementation had user engagement, the users loved it, it improved their data quality, but over time the system ran out of money because it was donor funded. And they had to appeal to the government now for help. Unfortunately, I'm sure you can guess what happened there. They couldn't get support. But there were also many other factors involved. Like it was during COVID and they had competing health interests. So obviously, unfortunately, they had to put the system away and get back to using paper systems. Now, the main lesson from that, obviously, is that for effective implementation of EHRs, there needs to be synergy between these two approaches. And if there's anything you can take from my presentation today, is that EHRs in South Africa are necessary, given the NHI coming. They're possible, given that we're a middle-income country. But if we're going to do it, we have to do it right. And part of this strategy is making sure these two are aligned. Otherwise, without EHRs, the NHI just might not work. Thank you.
Our second last candidate is Brian Karithi, supervised by Professor Yaya Chinara and Pradeep Kumar. And he's looking at 3D neuromimetic platforms for therapeutic intervention of glioblastoma multiforme. Yeah.
What if one injection could give brain cancer patients more time? Now this seems like a no-brainer, pun intended. And you may ask yourself, why time is the aim and not a cure? Well, for most brain cancers, unfortunately, like our cancer of interest, glioblastoma multiforme, aka GBM, not yet are we possible to have a cure, and there is no currently available curative treatment. In fact, GBM has a survival rate of 12 to 15 months with clinical intervention, and actually 3 to 6 months without. So individuals who are unfortunately diagnosed with GBM have time being a luxury that most cannot afford. So with this, we come back to our question. What if one injection can give brain cancer patients more time? Well, I'm glad you asked. We at the Thesis Advanced Drug Delivery platform have developed an injectable, thixotropic, thermoresponsive hydrogel system for delivery with supraparamagnetic nanoparticles with inside the neuromimetic ECM scaffold modeling system to use for GBM in vitro analysis going forward. Now I know that was a big mouthful and most of you would not have any idea what I just said, but let's put it simply. We have created an injectable jelly that has some medicine in it and some small iron oxide particles. This will be used for MRI imaging. We also have created some kind of 3D cell jungle gym for brain cells to grow in and to model the interactions with this particular injectable. We hope to have this injectable given during surgery and for it to have a more targeted and sustained release of chemotherapy drugs. Our drug of interest is carnosine. We also hope that we can look at this with MRI imaging using our supraparamagnetic small iron particles. From here, the aim is to go forward from this and to hopefully be able to give patients more time. In summary, all of this is really just a clear snapshot of what any healthcare practitioner would want to give more time. So far we have results that have shown enthusiasm with an injectable jelly being created, as well as our 3D structure also showing brain tissue properties. Both of them showing good promise for them to be used in this therapeutic. We are now testing in drug and cell work to show that this actually can be used as a therapeutic. In essence, we are trying to do something that most healthcare practitioners would want to do. Give patients more time to be with their loved ones, smell the beautiful flowers outside, and enjoy their last few moments. So we come back to our question one last time. What if one injection could give patients more time? Well, in our lab, I think we can. Thank you.
Great. All right, so we've come to our last presenter, Khanetso Sekome, and he's supervised by Professor Helen Miezwa and Francis Gomez Oliver Casas. I can never say his surname correctly. And the title is Contextualized Physical Activity and Diet Approaches for Hypertension Control in Rural Bush Coverage. And actually, Helen and I had visited Loughborough University, and it coincided with when they were doing their 3NT competition. So that's why we decided we're going to come back and implement it here. So over to you, Khanetso.
All right, let's go back to hypertension, which some of you might know as high blood pressure. Now, how many of you have had your BP checked, say, in the last 30 days? Maybe one, maybe two? Did you know, though, that in South Africa, every year, at least 75,000 people are diagnosed with a stroke? And the leading risk factor for that is hypertension. And also, at least 40% of adults are living with hypertension. Of that, only 9% have their BP under control. Now you may ask yourself, how do I control my blood pressure? The three main factors that are recommended is medication, physical activity, and changes in dietary lifestyle. But if we look at rural areas such as Bushbuckbush and Mpumalanga, the level of control remains even much lower because the interventions are not contextualized to meet the needs of those people. So my intervention then tried to bridge that gap by designing an intervention of physical activity and diet, looking at what people are doing in their communities every single day. What we did is I tested, designed, and developed an intervention that looks at the feasibility of physical activity and diet by making changes to the daily routine. So I looked at a model of behavior change called the COM-B model. What it says is the person capable of changing their behavior? Are there opportunities available in the community to change that behavior, and do they have the motivation for behavior change? With regards to physical activity, I profiled what they do every day. And I found that there's high volume of physical activity because people are doing something from the morning until they go to bed. But however, the intensity was very low. So my approach then was, let us try and find ways of increasing the level of intensity of what they're doing every day. With regards to diet, what we found is that there's lack of variety in what people eat every day. and their diet was mostly focused on high salt and high fat content. And therefore, our approach was, let's try and reduce the amount of salt of what they're eating every day. Because there's issues of affordability, availability, and preferred taste. So therefore, the results, because this was the feasibility study, we used the robot system, also called the traffic light system. Now the three things we looked at was retention, engagement, as well as recruitment and overall satisfaction. If the intervention comes to red, it means that we must stop, go back to the drawing board and relook at our intervention. If it goes to orange, it means let's go back and rethink what we can do better if we can roll out on the larger trial. And if it goes to green, it means we can continue and develop a larger randomized control trial to see the effects of the changes. And I'm happy to announce that my PhD came into the green. So now we are busy trying to roll out the intervention into a larger RCT, and I'm happy to share that outside this competition. Thank you very much.
All right, so I guess the time has come for me to announce I had nothing to do with it. And the judges said, and I agree, and I think we can all agree, the quality presented here today was fantastic. I think you can all pat yourselves on the back, and I really don't envy the judges having to sit and try and decide. Okay, so shall we start from third and work our way up? Okay, so third prize goes to Kuda.